So my name is Bandemer. I'm from Trend Micro. I'm leading the business acceleration team at Trend Micro. The responsibility of my team is to secure the cloud journey of our customers. But today, for those who expect a Trend Micro product show, I'm sorry, that's not the case today. I'm only doing the introduction. The main part is with Markus. I will introduce him in a minute. So for those who don't know Trend Micro, we are in the cybersecurity sector for over 30 years. We are a pure security vendor, and one of our strategic focuses is cybersecurity. As I said, for me, I'm really honored to be on stage with Markus Junior today here. Markus Junior is from Hannover, and he will tell you something about how he secures the cloud journey of Hannover. So he will talk about server-free security controls. And as I said, you will not hear anything about Trend Micro. I believe there's one small slide where you see a Trend Micro sign. But if you want to know more in detail, in depth, what we are doing to secure your cloud journey, please visit us at our booth. I have to leave. At our booth. If you go outside, straight ahead, close to the catering area. So not far away from drinks and from the food. So, but now I've talked enough. Please, Markus, come to the stage and the show is yours.
Thank you. Yeah, thanks everyone, and thanks a lot for the introduction, Kai, and also for the opportunity to speak here. My name is Markus Junior. I very welcome you to the session Server-Free Security Controls, how to tackle security threats without lifting heavy infrastructure. No one wants to do this anymore. So I'm working for Hannover. If you wonder what Hannover is doing, we are a reinsurance company, so we cover the risk of first insurers. But that's enough, so no more company slides what we are doing. I'm working in the internal IT department. There I'm a member of the AWS cloud team of Hannover, and my main focus is the security of internet-facing applications, so e-business security. Let's get straight into the topic. Security controls are not just one more firewall. It is not just one more brick to your very first line of defense to make it even more difficult to conquer your environment. Instead, security controls are measures to avoid, detect, and counteract, so respond, in best case, by automation to any kind of threats. What does it mean? In our opinion, security controls contains of three different pillars. The very first one is avoid and protection, our well-known first line of defense, so our homework. Everything what we do to make sure that the system cannot be harmed. So we have least privilege here, we have minimized system, segregation of duty, hardening, all that stuff what we do for the last 40 years. However, for security controls, we have two more pillars. The second pillar is all about transparency. We call it detect. In the detect pillar, we want to detect in real time all events and actions by logs and events, raised events, what's going on in our environment. Actually, it doesn't matter if it's in the cloud or legacy on-premise. We want to ensure visibility here. Secondly, we want to ensure auditability. Auditability means we have to avoid that the log files and the events will be stored on the system where it occurs. We want to store the log files centrally. The reason for that is simple. If a hacker would conquer your environment, the very first thing what a hacker will do is trying to postpone or pause your logging mechanism. Or later on try to alter the log files just to hide his own traces. So make sure you centralize your log files and you keep it away from the system where it occurs. The third pillar is all about respawn. We want to trigger notifications. We want to trigger alarms. And yes, also the idle incident is still there. So it doesn't change here also if we talk about server-free. And maybe in best case, we want to respond by automation with mitigations and counteractions. Let's don't waste time here. Let's get to an example. Again, we have our three phases here. We talk about now about SSH. We want to SSH to a host to remotely manage the system. What is our usual first line of defense, what we all know? We do the hardening stuff. We avoid that we have privileged users who can SSH to the machine. So we disable root for SSH. We disable also for authentication that we accept passwords. And we only accept keys. And maybe we restricted the source IP range also to a CIDR range just for the Bastion host. These are all measures for the very first line of defense. The question what we have to ask is, do we have anything also in the detection phase? So do you actually log failed login attempts in the secure log? And if you do you store it on the system where it occurs? Or do you log the secure log outside of the system in a central place where it cannot be altered? And can you also distinguish between malicious and regular behavior? For example, it could be malicious if you have always on a Sunday night a huge campaign of brute force SSH attempts slowly, but also only during the night against all your hosts. Looks suspicious. Instead of a user who just one time mistakenly used the wrong code, host name or key file. In the respond phase, in this particular example, you have maybe to ask yourself, do you mitigate or counteract this kind of security threat or issue? Mitigation in terms of SSH could be after 5 unsuccessful SSH attempt, you slow down further attempts and you have put in a delay of 5 minutes. Counteract is the more aggressive route, the more aggressive approach. You actively block the source IP forever or for the time being by an object-based firewall. And then, do you escalate the event? So, do you know what's going on? If you have, if you recognize this is a serious issue, maybe. So, do you raise notifications and tickets? All of that is something what we do in a server-free environment. Server-free does not mean container. So basically, when we talk about server-free, we use really the huge portfolio of AWS and also others to use these kind of services. So here's just a few examples. We strongly work with Lambda and also with CloudWatch and other services here. And also, and here's the Trend Micro logo, of course. We use Trend Micro here, and especially their security cloud approach to integrate their DLP, so data leakage prevention and antivirus stuff, into our security controls. So we have a fleet of EC2 instances, for example, with, I don't know, more than 1,000 EC2 instances, and we have the agent of Trend Micro here, and if we have an issue, then we will add it to our workflow, what we will see later on. When I talk about that we use Lambda quite heavily, I have a few figures with me, some metrics. In 2020, we started with security controls, and we had about 100 million Lambda invokes just in our security account. That's already quite a lot, I guess. In 2021, we already had an increasement to 250 million Lambda invokes. The reason is not that it's getting more insecure and insecure, actually our consumption increased. And also the portfolio and the bandwidth of our security controls itself. Server-free, maybe I have to disappoint you, server-free does not mean free of cost. When we talk about the cost, they are quite reasonable in my opinion. So for a 12-month period for our security controls account, we have 250 million Lambda invokes and a total of $19,000 US for the whole 12 months. So that means a monthly average of 1,500 US. Not too bad. And if you take a closer look now to the chart, you see that Lambda is actually just the purple fraction here. It is just a fraction of the cost. We also rely, obviously, on CloudWatch because we use it for log files and also for the event rules and stuff like that. And also we use GuardDuty. We strongly recommend to use GuardDuty also in this kind of centralized deployment, what we did here for the security account. Because it's a very, very useful let's say, resource and source for security issues, what's going on in your environment. And also we have QuickSight. We use QuickSight to add a visualization layer to our metadata so that we have a fancy dashboard in real time and we see what's going on where. And we do not have to add any kind of other software. And offer other stuff like S3, etc., etc. Okay. Let's get now first to the very first architecture, and I will lead you in that, through that in detail. It's about public S3 objects and public S3 buckets. And maybe you heard about that in the press that several companies suffer a huge breach because by misconfiguration. It's not that S3 is insecure. By misconfiguration, someone, it was not intended that way, and therefore they exposed their bucket to public, and that brings a lot of trouble. So how to get out of that, and also how to detect that and how to mitigate that immediately. First of all, our workflow here for security controls. In the upper bar, you see the very first phase. It's about the visualization. So we have here the event source and log source, what's going on. Then next is the detection phase. So the patterns. Where can we decide what is a regular and suspicious behavior, and how can we decide if it's important to react or not. The next one is mitigation and counteraction. If we know what to do, we want to deal with that immediately and counteract immediately. We do not want to waste any time to raise a ticket to someone to do it manually. The last phase is notification. We raise tickets, we raise notification, etc. But in best case, it's already solved. The bottom bar is all about auditability, so we do the logging stream about the whole phase. And then we have 3 more lanes here. The very top lane is the suspect account. So we have a multi-account structure. And maybe if we are working in an enterprise, you know that as well. You do not have only one account. You have dozens of accounts, or like us, 100. The very first one is the workload account, so where the user is working. The middle lane is our security account, our controls account. In this account, the logic is ongoing and the processing of the security threat. Logging account, obviously, all of the button is where we store the log files. All right. Scenario explained. In this scenario, we have a user, and this user has been is authenticated successfully and is authorized in the workload account. And the user is able to work with this specific S3 bucket. That's all right. That's okay with us. And now the user is dealing with files and objects in the S3 bucket. And now by mistake, or you don't know even better, or you would like to share that with a colleague or a client, the user is now changing the access control list, or the bucket policy, or the permissions of the file. And by mistake, he will expose the object to public. Well, we could have an issue here. Luckily, there is a service of AWS, and the service is called CloudTrail. CloudTrail will actually record all actions, what is going on in your environment when someone is dealing with your resources. It doesn't matter if it comes from an API, like from a Lambda. It doesn't matter if it comes from an EC2 instance, or from a user in a UI console or via CLI. And now we need one more service. Next step, we are in the detection phase, and we use CloudWatch in the source account, and we look for a specific pattern. And the pattern is, in this case, has been exposed to public. As soon as we see this metadata and this pattern, we will add the metadata and put it to an event bus, and we push it down to the security account. All further processing will happen in the security account. First of all, we add it to an SNS topic, and then to an SQS queue. The reason for that is all about scalability. Maybe we have to deal with thousands of events at the same time, in the same minute, in the same second. We don't want to do one by another. We have to really use here the scalability of the cloud. Further, in the detection phase, we look for exceptions. We have now a whitelist check, and this whitelist check will actually go down to a DynamoDB and look if this object or S3 bucket is maybe whitelisted to get to be configured to be public. Maybe we want that. And if we use it by, let's say, if we prevent everywhere globally that this is possible, maybe we will prevent then an opportunity what we would like to have. So therefore, we manage it here. If it's not on a whitelist, if it's on a whitelist, that's the first case, the good case, the process will end. Nothing will happen here. However, if it's on the whitelist, our Lambda will then do the mitigation and counteraction by automation. It will jump again back to the suspect account and will reject the change of the user and will put it back to private. The whole chain takes just 1 or 2 seconds from changing to public and back to private. Maybe the user is wondering why he's clicking all the time the buttons and it does not work, but that's how it is, right? So, and maybe that we can talk to the user, we will raise a ticket and we will raise an alarm. And then we can pick up the phone, hey guy, what you are doing there? That was the first example. Next example is about compromised EC2 IAM keys. This is all about vulnerable applications. And maybe you heard about this server-side request forgery attacks. So, and there was a very popular one back in 2019 for Capital One. They lost about 100 million social numbers in the US. That was quite horrible. So what is the server-side request forgery attack in short? By an application, an e-business application, an attacker was able to conquer the application and was able to trigger the web server, the EC2 instance, to request an URL in the context of the server, not in the context of the attacker. Sounds not that too bad, right? But however, if you know that the access keys and secret access keys of the EC2 instance is in a local metadata service, then we are in big trouble. So what happens back in the day at Capital One, an attacker was able to conquer this application, was able to trigger this attack, and then just take the current EC2 access keys and secret access keys of that instance. Uses that on that, his own machine, and then from his workstation just leech the whole S3 bucket. Thank you. That's all. Then you are done, actually. Okay, now we have that assumption how to deal with that issue. Again, we have in the visualization layer and phase, and we have now the assumption that the user from the outside is using access keys against the API of AWS. And so no issue so far. However, there is a service, guard duty. And guard duty will actually recognize that we have maybe a suspicious action here, because the source IP of the attacker, of the user, does not match to the EC2 instance. And that looks really strange. Again, we have this information by guard duty, but you have to deal with that. We have again, then in the detection phase, CloudWatch rules, and CloudWatch rules will exactly look for that pattern. So, and it will react as soon as we have this issue, IAM credential exfiltration. And we use it again, the metadata, and put it down to the security accounts. Again, we have this workflow with the SNS topic and SQSQ for scalability. And then we have a Lambda with a whitelist check. Why on earth shall we use a whitelist check for this kind of behavior? This looks really, really suspicious. The reason is legacy environments and compliance issues what we have. And if you're working in an enterprise, you are maybe enforced by your network colleagues on-premise. You have to use the proxy server and internet outbound breakout of our company and not the NAT gateway or internet gateway of AWS. Okay. And then they have to get back via the tunnel or whatever. The only issue is, if an EC2 instance is doing that, the source IP is obviously different. Then it's the source IP of the proxy server at home. And therefore, we use this DynamoDB here and add our own ASNs or well-known IP addresses of our proxy service. If it's on the whitelist, perfect, we have no issue. However, if it's not on the whitelist, we have to assume that our EC2 instance and our application has been conquered. And we have also to assume that our keys are conquered then. And we have to deal with that immediately. The very first thing what we are doing is we actually take a look if this particular EC2 instance belongs to an auto-scaling group, and we disable the process to terminate the instance. The reason for that is we would like to do digital forensics later on. Therefore, we have to make sure that the system will not go down. Second thing is we will isolate the EC2. We do this by just replacing the security groups. And the last thing is, obviously, maybe we have to revoke the keys, just to manage the blast radius and manage also the breach. Then we will raise tickets to our ticket system. We have here ServiceNow. We use the API for that. We will email that to our SecOps team. And also, I explained in the beginning that we use QuickSight as a visualization layer. We use the metadata, put it to a database, and use QuickSight to have a fancy website. So that's the second example. Session almost over. A few key takeaways. The very first thing is, please do not just count on your first line of defense. I know that we spend a lot of time and effort to do all the hardening and all these kind of security features to make it even harder for our developers to work with AWS, etc., and we have all these kind of fancy tools. But the main issue and the main reason for breaches is misconfiguration. And that's the main reason. So it's not about that the cloud itself is insecure. So hacker do abuse misconfiguration much more than vulnerabilities. The second one is deal with the data tsunami. You heard about that. 250 million Lambda invokes. It's just incredible, a lot of metadata. And if you do not deal with that, and if you do not reduce the false positives, you will just overwhelm your teams. They will not react anymore. Makes no sense for them. So therefore, please conclude your data and conclude it from data to information and then to wisdom. And lastly, automation is really mission crucial. Automation is key. It makes no sense if you exactly know what to do to solve an issue, if you recognize a threat, to just raise a ticket and wait for someone, human being, to react on that threat. It makes no sense. Because time is ticking and maybe you have to deal with that immediately. So escalation is good, but automated counteraction is best. That's given. Thanks a lot. If you would like to reach out, my email address. Thank you for your attention.
Thank you, Markus. Since we have some time left, so are there any questions regarding the presentation from Markus? Please feel free to ask them now, and we do our very best to answer.
Or we catch up at the Trend Micro booth just around the corner. Can do this in English or German, I don't care.
There is a question. Oh, okay.
From far behind.
I believe you have to come.